Alright, we're going to go ahead and do 31 through 60, this section. So point -5, 4 is reflected over the x-axis. So if you're reflected over the x-axis, your rule will then become x negative y. So we're given x comma y, so we're going to just get the same x, and the y is going to become negative. So -5 comma -4. The y equals x line means we're just going to switch the y and the x. So if we have x comma y, this is going to get switched, so we'll get -2 comma 3. The y equals negative x line means we're going to get switched and go opposite signs. So this is going to become +4, +2. Number 34, a glider reflection glides all points 8 to the left, then reflects them over the x-axis to find the image of 6, -4 under this transformation. So do 6, -4, this is where we're going to start. We're going to go 8 to the left, 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to reflect over the x-axis. So how many units away we are from here is 4, so we're going to go 4 in the other direction. And that should be our final point at -2 comma 4. Alright, chapter 10. Find the measure of one exterior angle of a 42-agon. Well, the sum of the exterior of every polygon is 360, so we just divide it by 42. And we're going to get 8.5 about, I believe, if my math is correct. Yeah, about 8.5, 8.6, we'll say that, round to the nearest tenth, 8.6 degrees. Next, find the measure of one interior angle of a 32-agon. Well, we have to find the sum of the interior first using this formula. Okay, so it's 32-agon, so it's going to be 180 times 32 minus 2. So we're going to get, let's see here real quick, 5,400. So that's the sum of the interior, so we want 1, so we just divide it by 32. And we will get our answer of 168.75 degrees. Find the sum of the interior angles of a 28-agon, so it's the same thing as the one above, except for we don't have to divide by 28. We just go ahead and put that in the calculator, so it's basically 180 times 26. So we get 4,680 degrees. The sum of the exterior, this one's really easy, it's 360 no matter what. If the sum of the interior is 2,340, how many sides does the polygon have? So what we could do is just take the formula and set it equal to this number and then solve for n. So divide by 180. So 234 divided by 180. So we get n minus 2 equals 13. Add the 2 over, and n is going to equal 15 sides. The measure of one interior angle of a regular polygon is 165. How many sides does the polygon have? A couple things you could do here. Remember, if this is the interior angle, the exterior angle is coming right off of it. We know the exterior angle and the interior angle together should add up to 180. So the exterior angle here is going to be 15 degrees. So I could literally just take 360 and say how many times does 15 fit into that? And that should be how many sides we have, which is going to be 24 sides. Okay. So 10 questions down already. Nice. Alright, so if the measure of one exterior angle of a regular polygon is 12, how many sides does the polygon have? So it's basically the same thing we just did on the other page, except for now we're dividing it by 12. So we're going to have a little bit bigger number, 30 sides. 42, find the area of the figure below. Well, we kind of can make an imaginary line here and find the area of these smaller rectangles. So that's a 12 by 9, which is going to be 108. And then what we have here is we have the bigger one, which we know the side has 13, but I want to find this piece right here so I can multiply those two. So the whole thing is 21. If I take 21 and I subtract 12, that means I'm left over with 9. So I got 9 plus 12 is the same as 21. So we just do 9 times 13. We get 117. Add those two together. And that should be our final answer. And we'll go units squared because we're talking about area. Find the area of the polygon, or sorry, parallelogram. You just have to do base times height. And that should be a 90 there. It wasn't, but it should have been. So 8 times 12. We get 96 square units. Or, yeah. Find the area of a regular heptagon. The apothem is approximately this, and the side is 14. Well, the area of a regular polygon is 1/2 a times p. So the perimeter, 14 heptagon is 7 sides. So we're going to get 7 times 14 is our perimeter, which gives me 98 is our perimeter. So we get 98 times the 5.58 apothem, and then divide by 2. So it's kind of nice that they give us the apothem, makes my job easier, and we get 273.42 square centimeters. Okay. 45 is also actually pretty easy. This should have been a 90 degrees. Area of a triangle is just 1/2 base times height. Base will be 25, height will be 14, and then take half of that. So kind of a simple one. We get 175 square units. Alright, 46. Find the area of a regular hexagon with a side length equal to 8. So this one's not as easy. This one's probably one of the more difficult ones on here. So I'm just going to draw a hexagon real quick, a 6-sided figure. So we have side length equal to 8. So again, our formula is 1/2 apothem times perimeter. So if a hexagon is 6 sides, we're going to do 6 times 8 equals our perimeter. And 6 times 8 is going to be 48 for the perimeter. But now we have to find the apothem. Remember, the apothem is this little altitude, if you will, in pink. And it's the altitude of the triangles that you can break up the hexagon into. Again, because our regular polygon formula is basically solving the area of all 6 of these triangles. So the apothem is that piece right there. Okay. So first thing we do is we take 360, we divide it by 6, that gives us 60 degrees. So in each one of these central angle pieces, we have 60 degrees. I'm going to draw this small triangle out a little bit larger. And we have the apothem here, the piece in pink. And this is only half of that full triangle down there, so this is going to be only 4. And instead of 60, this is going to be 30. So we have a 30, 60, 90 triangle. And if 30 is 4, this is going to be 4 rad 3 for our apothem. So we just do 1/2 4 rad 3 times 48 and leave an exact form, so we're not actually going to touch the rad. So I'm just going to do 48 times 4, divide it by 2, I get 96, slap on the rad 3, put on my units, and I'm done. Find the area of the trapezoid. Well, that's pretty easy if you know the trapezoid formula. Another good thing for a note card. Base 1 and base 2, so we get 13 and 15. And then the height is 10. Again, there should be a 90 degree here, but there's not. So we just have to evaluate that. 13 plus 15 is going to give you 28. Times 10 is 280. Divided by 2 is 140 square units. Find the height of the trapezoid given its base measures, and its area is equal to 126. So I'm actually going to use the same formula up here, but instead I have the area of 126. I don't have the height, but I have the 2 bases, 10 and 18. So we can just use some basic math here. This is going to become 28 times h, 1/2 equals 126. I can actually take half of the 28, so I can get 14h equals 126. And then just divide 126 by 14, and I get h is going to equal 9 centimeters. Find the area of a rhombus who has a perimeter of 40 and one diagonal that measures 8. So the area of a rhombus is 1/2 diagonal 1 times diagonal 2. And diagonal 1 is going to be 8. It told us that, but I don't know diagonal 2. So to find that, the perimeter is 40, 40. So we get 10, 10, 10. And so we get 10 in each one of these spots. One of our diagonals is 8, but since we know all about rhombuses, our diagonals are bisecting. So the 8 is going to actually get split into 4 and 4, and it creates a 90, so we got a right triangle. And so we can actually find this little right triangle here, and if we find this missing side, that will be the other part of our diagonal. So we're going to get 10 squared is the hypotenuse, 4 squared plus, we'll call that the x squared. So doing the math very quickly, we get roughly we'll just roughly call x 9.2, again rounding a little bit, and so if we get 9.2 here, 9.2 is also there because it gets bisected, so we're going to roughly end up with 18.4, and then we're going to take half of it. So we get 8 times 18.4 again. 18.4 comes from the full diagonal of 9.2 and 9.2. And so 18.4 times 8 times, or actually divided by 2, should leave us with the answer of 73.6 square centimeters. Alright, we're 20 in, almost done. This one's really easy. We get 1/2 diagonal 1, which is 10. And then we're doing, and the second diagonal is 7 plus 7, which is 14. And so we're just going to get 10 times 14, which is 140, divided by 2 is 70 square units. And now we've done 20 problems. Woo! All right, find the area and circumference of a circle whose diameter is 24. This is so easy. So area is pi r squared, and circumference is 2 pi r, which 2 pi r is the same as pi d, so the circumference is literally just 24 pi. And then centimeters. And then the radius is going to be half of that, so that's going to be 12. So we're just going to do area equals 12 squared, so that's 144 pi. And then we're going to have square centimeters because area is in terms of centimeters, but they're squared. All right, let's go 51. I guess, oh, actually, we skipped one, 52. So bonus hockey. Awesome. All right, so this is volume. So volume is the area of the base times the height. You can pick your base area. I'm going to pick this one. For base area, you have to have 2 congruent and parallel bases. So I'm going to do 3 times 9. And then the height is going to be 4. On these ones, you could really just multiply all the numbers together. And you're pretty good. But 108 cubic centimeters. All right, this one not so good. So you have to be very confident that you have 2 congruent and parallel bases. So these are the only 2 congruent parallel bases. So when we do our volume formula of big B times H, that big B is actually 1/2 base times height, because this is a triangle. And then the height of the prism is actually 19. Okay, so you gotta be very careful when you set that up. 15 times 8 divided by 2. So the area of the base figure is 60, and then we multiply it by the height. And we get 1140 cubic inches. Okay. Moving on, this one's a little bit easier because we don't have to differentiate between things. It's just pi r squared because the base is always the same, times the height. We'll leave it in pi. So we have 10 is my diameter, so we're going to get 5 squared times 14. So we'll end up with 350 pi. And that's in no units zone, so we'll just go cubic units. Seems to be fair. All right, the volume of the cone shown below. So the cone actually has a very similar volume. We just have to do this like 1/3 thing before it. That's squared, sorry. So we have the height here of 40. And we have this thing called slant height, but I don't want that. I want the radius. So we're actually going to solve for this little guy. Because it's a right triangle, we can do that. We're going to get 40 squared plus r squared equals 41 squared. And so I'm going to solve that in my calculator really fast. and we're going to get r equals 9, believe it or not. So we get 9 squared and 1/3. So there's our equation right there. So I'm going to evaluate that. So I get 1/3 times 324 pi. So I'm going to take 1/3 of that, which basically means I'm going to divide. So I just did 9 squared times 40 is what gave me that number, 3,240 pi. So divide that by 3, and we get 1080 pi, and that's going to be in cubic centimeters. So the volume of a pyramid is very similar to a cone. You have that 1/3 there, then it's big B times h. The base is going to be the square base right here, and the height is actually given to us pretty easily right down the middle. It's like taking that elevator up to the top, not our slant height, not what you want to slide down. Okay, so we get 1/3 of 18 times 18, and then the height is 20. So just kind of throw that all in your calculator and YOLO, you know what I mean? And that's in centimeters, so we have cubic centimeters. Volume of the sphere has a diameter equal to 24. So the volume of the sphere is 4/3 pi r cubed. The radius here is going to be 12, half the diameter. And so we just plug this into our calculator as well. I'm going to leave it in terms of pi because it makes the most sense. So 12 raised to the 3rd power is a pretty big number. So I got this as my number, let's see if you can see it, 1728. Now what I'm going to do is I'm just going to multiply by 4, and then I'm going to divide by 3. That's how I do it. It just makes it easier. So 2304 pi, and that's in cubic centimeters. All right. Write down the ratios for scale factor, surface area, and volume. So this is super easy. A to B, a squared to B squared, and a cubed to B cubed. Okay, again, what we got to remember is that these pieces do need to be one-dimensional scale factor, area two-dimensional, volume three-dimensional. That's why we have exponent of nothing, it seems like, but there's technically an exponent of 1 on A, exponent of 2, and exponent on 3, relating to the number of dimensions that you have for each. So the surface area of two solid similars is 16 to 48. So 16 to 49 is your a squared b squared. So you want to find the a cubed b cubed, and you want to find the a to b. Okay, to go from here to here, all right, we need to square root. Okay, so we're going to square root 16 of 48. So 16 the square root of, 49 the square root of, and we get 4/7. Okay, and then to go from here to here, we need to cube. Okay, so we take 4/7 and cube it, and that will give us our final answer for our volume ratio. So it's kind of like a back and forth type deal. I think it helps kind of drawing a little picture. So to go, if you have a squared b squared, you have to square root it to go to a to b. Once you have a to b, you can go to a cubed d cubed by cubing it. Last two. All right, we didn't quite finish the chapter. Maybe I'll just go all the way through the chapter because it's like one more problem, right? Yeah. If the height of cone A is 9 inches, the height of the similar cone is 12 inches. Okay, so we got 9 to 12. That's an A to B. And the volume of a cone A is 108, so that will go on top. What's the volume of cone B? That's A cubed to B cubed. So right now they're not equal. So to make them equal, I'm going to have to cube these. And then we can say, yeah, they're equal. And so we get 9 divided by 12, which we could reduce to 3/4, and then we could cube that. So just kind of making the numbers a lot smaller. We could go to 3/4 cubed equals 108 over x, and then that actually cubed is 27/64, which equals 108 over x, and then we can cross multiply 64 times 108, and then divide by 27. And we get 256 as the volume of cone B, which is in cubic inches. Find the area of a circle whose circumference is 48 centimeters, leave in terms of pi. So circumference is 2 pi r, so that means 48 equals 2 pi r. So I just basically have to divide by 2 pi. So 48 divided by 2, and let's use parentheses so we don't make a mistake, and pi, we will get the answer of 7.6. So our radius is about 7.6. So we'll just put that into our area formula of pi 7.6 squared. I'm leaving it in my calculator, so I'm going to get a little bit better answer than you. And we're going to get 58.4 pi. That's going to be in square centimeters. Find the circumference of a circle with a diameter equal to 12 or 14. That's so easy. It's just 14 pi. Done. Thank you for joining.